talk about. So now, what the structure diagram is. Mind it that the structure diagram, as our syllabus says, that it is a top-down design in a diagrammatic form, which is obviously in a um, hierarchical and showing how a solution can be divided into subsystem with each level given a more detailed breakdown if necessary. So it's not mandatory that each level must have another subsystem on it. If it is going to, finalize at a particular level, probably I'm designing a very simple software, which means that sort of a notepad type of a file. So typing is one part of it, right? And you can save it. So this is one part of it. So let's open Notepad for a while to understand that what I'm talking about. Okay, let's go for, excuse me. Let's have a new one. So I have like this particular area with the Notepad, and then on Notepad you can see the file, and file is obviously having multiple things on it. What the multiple things? It's a new tab, new window, and make new markdown. The open is very common. Save as is obviously common. Similarly, we have close and the print is very common. So let's try that if I might design something, some notepad with the file menu, and in a hierarchical way, I have open, save, and print only. So what I'm designing over here, if suppose for a while, if this part is a notepad, so on this area, let's suppose this is a file menu, and this file menu, I might design things moreover or probably print, save, and probably open. Let me take out my pen. From, this is not the writing of the pen right now. Hold it for a while. ऐसे वक्त में कि हम लोगों पे एग्जाम राशि रहे मगर भारी इंसान मौका नहीं Yes. So, yeah. So we can have, you know, print menu over here. The second one is can be open and the save. So this should be in a box. This should be in another box and so on. So you can have understanding of that if we have this one is an edit menu and the other part is I think was what view menu. You can have multiple options available over here, right? So this is our topic through which we can go for certain actions. Now, why we named it as top-down design? Because we have a particular target, and this particular target can be achieved with once we are bifurcating things out. So that's the real task. And in the green area, it is already written that the decomposing our computer system into a set of subsystem, then breaking each subsystem down into a set of a smaller subsystem until each subsystem just perform a single action. So this means basically that we are trimming it down, chopping it down into pieces and pieces and pieces till we are going to resolve a certain issue. And that is the entire making of our entire uh, software, or if you named it as a program as well, because we are studying program development lifecycle. Okay, what does it look like if it is a structure diagram, an application for alarm clock? An alarm clock might have input, process, and an output. So the top part is an alarm clock. Then we have input, process, and an output. Then we have further parts on input. Yes, as you can see that with the help of input, we are going to have the set time, turn alarm on and off, because you're going to, completely, uh, switch it off, removing it, that I don't need this alarm now, just because of that, like whatever is happening. Now you need another alarm. The process is checking of the time. This is what we have already discussed, that checking of time will be dependent on means probably a second or a 5 second delay or a 10-second delay. So if you reach, let's suppose this is right now, if we are setting an alarm for 1 o'clock today, this means that you're basically designing the entire thing. Uh, right now, this is 12, I think 40. So after every probable 5 seconds, you're going to check that have we reached 1 o'clock, adding 5 more seconds on it, whatever the total is, and then going to check it again. So the time check process is little bit, hassle for a computer. Anyway, the final is an output where you're going to sound the alarm. And the sounding alarm means that you are generating an output with the help of turn off and on, because you wanted to, you wake up, so you wanted to, pause it till next day. Now, what is the answer of this one? A solution to a problem may be represented using pseudocode, flowchart, or what? Can you write it in the chat box? Yes. Straightforward, you have an answer from Shafe and Vanya. Both answers are correct. And this is structure diagram. And obviously, Vanya as well. So we will have like different answers. The structure diagram is the third part of the solution to represent as an algorithm, or solving the problem out. Now let's move toward another system. Now you need to identify a few things, and I would like you people to tell me that how to design it. A food ordering system is an example of a computer system that is made up of subsystems. Okay, the food ordering systems allows the user to enter detail of a food they want to order and to pay for order. Okay, display food available as picture or as a list. Complete the structure diagram for the given parts of the food ordering system. The food ordering system is already, the top layer is already written. I need your answers to initially do, we were not directly going for the designing. We need to identify things first, that on this point number one, on this point number one, what we have. Now, on this point number two, what we have means that the first part, if I might design over here, will be like the second part, if I'm going to design, will be like what? And then there are further more things which we have to work on. So, can anyone tell me that what it might look like? Because we have two bullets. Let's go further with the technique, right? We have two bullets over here, which means that two subsystems are coming. But how many further subsystems are coming with these two, and what are the names of these? This is what we have to write. Hopefully, this is understandable now. And let me go back a little bit to show you that what possibilities can we have once we are thinking about an alarm clock. Now, you don't have to think about it. The things are already given. The food ordering system, the top layer. The second layer is allow user to enter the detail of the food they want to order and to pay for the order. Okay, let me highlight it for you people. So you will be, you will have a little understanding of what we are basically talking about. Till here. What is your understanding for it? Joffrey, 100% correct about it. That it's an input. So let me write input over here. And what should I write on the second side? Means if I might highlight this area again. Shafi is talking about output. Now they used obviously I can write it output, but they use the word display. So I can write it either display or output. Both are obviously correct. But as you say, that output should be there. Okay. Now taking another step down. Another step down from here. Another probable step down from here. Allow the user to enter detail of food they want to order and to pay for the order. Right? The second thing is food available as pictures or as a list. So what should we do? ये एक ही आदमी जवाब देगा क्या? ये एक ही लोगों का जवाब क्यों आ रहा है? बाकी लोग क्या कर रहे हैं भाई? Answer is basically from Shafi again, that the food item in the payment details under input, but uh, under input we can write these two elements, food item in the payment detail according to Shafi. And what about the output? What do you think about output? Please be a little quick. I have already explained it. Let's do it again. It's like top-down design. This is what your understanding is. So the question is written, by the way, and the question says that there is a food ordering system. This is a food ordering system over here. This one, the food ordering system they are talking about, right? Now, what is happening with the food ordering system that allows the user to enter detail? This word allow the user. Yeah, we have answers, but let's talk about it first. Allow the user to answer the detail of the food. So allowing a user to enter means that we are going to input or someone is going to input data, right? But the inputting, I'm going to input about data what? So entering the data, excuse me, entering the data, but I want to order and enter the data about how to pay for it, as well as how can they look, how can they have the information about what the food is available. So it can be, plays on obviously display or output with the help of a list or with the help of the pictures. So it's very straight, very simple that under output, you're going to write pictures. Under output, we're going to write list. So if I might do it over here, I should write picture like this and can write the list like this. Now display option can be either output or display options. Both are correct. And here we have three things. Display choices. What are the display choices? Is this written somewhere over here? Enter the detail of food. That's the choice. This particular part. The detail of food. They want to order. So if they wanted to order, the food order should be there, the payment detail should be there, and the rest of the things. So if you're going for the marking scheme for it, this is how you're going to solve it. In some conditions, on some questions, the examiner have done designing of the few things by themselves. Means probably this area, this particular area they have plotted, this particular area they have plotted, and the rest of the things they are asking for. But again, our understanding and our designing is from the scratch. So this is what they have done, and the 4 mark are being awarded for the hierarchical suitable hierarchical structure like this, as well as the name of the things. Yes, you can write like whether the word picture was used in the question, so we are going to use it. The list is used in question, so we are going to use it. The payment, the like pay the order, so you can write uh, payment method if you wanted to, but this is appropriate. Food order and the display choices are also very important, that you are going to input this. these choices so the user can view it once they are going for the display options. So this is one question we have, a simple type of a question, which the examiner is going to ask about in top-down design. Uh, okay. Now, the next part is the security system on a door allows a user to type a code into keypad to enter the room. If an incorrect code is input, an error message is shown and a short alarm sound is displayed. Can you design the code for it? Please write the question. We'll discuss it in probable it's a sort of like assignment for you people right now. Just design it, just write it down, take a, like a screenshot of it, and we'll discuss it later on in some other class. Probably tomorrow if we have like let's suppose online session, or probably on site session. Because I want to move on to another thing. So is it done? The question is noted. Have you noted down the question? Very quickly. All right. So now let's move a little bit forward. Algorithm flowcharts. Now, this is obviously after the top-down design, or if you named it as structure diagram, then we have another one, which is algorithm. The, the algorithm is obviously it's a set of instructions solving a problem to accomplish a task. And we are going to use sequential ordering system, instruction systems for it. So I'll obviously going to send this particular slide to you people. You can note it down. Example of an algorithm, real life. What the algorithm is. Walk to the parking space, open the door, turn on the engine, put on your seatbelt, and let's go. So this is very common for us, right? Driving a car. But what if you are going to, send all this information to a particular robot and asking him to do certain things? If probably the door is locked, then what should the particular robot is going to do? If the robot is going to, open the like obviously walking to this space and the door, how to open the door, then again, if the engine is not starting, then let's keep trying it or wait till after 3 to 4 attempts. So these are the simple parts which we need to, talk about. In the alarm clock, this is what we have done. For every 1 second check, if the time matches, if the time match checks, if today, if the days match, example like weekdays, if both match, then send signal to the sound system, which will link the sound. Okay, so we are chopping down again things into multiple pieces. Now talk about this particular place, which is the flowchart. And you people have already told me that you have done some part of it. So instead of going for whatever is happening inside this particular statement, let's try to find out very quickly that have you ever gone through with these things? The the start and the stop sign is known as terminator. Please mind it that this is an examination question solution. That again, terminator, you're going to name this one. The process, if this type of a box is there, then this will be process box. Input and output will be like it's like sort of a category brand tilted toward the right side. Don't write input and output at in processes area. Then we have the decision box, which will have two output statements. Anything which is coming like start is holding one thing, stop is holding one arrow. The sound is also doing it, but input and output is holding. It's coming from somewhere and going down somewhere. But for decision box, you have to, go for two different things. Then this probably is a new for you, subroutine. Subroutine is a complete program itself. We don't care about what the program is doing, but with the name we can find out that what the program, this small program inside my program is doing. So the get time means that represents a small procedure running within the large program, and the abstraction in action is basically happening over here. We don't care what is happening with this program. We are using it. Simple. So the program code is written somewhere in our program. We don't care what the code of this particular program, but it will reach out, get the time of the system, and probably we are going to compare it with our own system. And the flow lines are very important, obviously. This can be, the flow line can be, go right, left, up, down, whatever. So let's come back to this system now. As you can see, it's a start from here. Get time means grab the time from the system clock, check it. If the time is equals to alarm time, what the time? This time. The system time is equals to alarm time. If yes, then sound the alarm. If no, then this is the wait for this 30 second, and we have the understanding of that we cannot go for the 30-second area. We can go for 5 second or probably 1 second. After 1 second, we are going to check it again and again. So please mind it that these are the terminator, decision, input output, subroutine, process, and the other things. Now, this here we have a straightaway examination questions. I'll forward it to you because we have a very limited time, few seconds are remaining. So I'll forward these questions on your WhatsApp group, and you can answer these similar type of questions to find out that either you are able to solve it, yes or no. So till this slide, I'm going to 3 slides data to your group to find out that either you are able to solve it, right? And I think that's it for today. We are going for the discussion, the conditions and the other things later on. Yeah, I'll share it. I'll share the slides. Yes, sure. All right. Uh, wait for a while. Let me take the attendance.